Alrighty, here we go. It's the review for Chapter 8. Now, we have had 3 days in class to do this. So, hopefully all of your questions have previously been answered. But if not, I'm going to do a couple of examples from each section. It's a pretty brief chapter. So let's get going. So the first part is based upon the Pythagorean theorem and how we can manipulate it to solve for each of the sides. So if we know that a squared plus b squared equals c squared, then the rest of this can be said to be true. Now this we went over, I believe it was April 23rd-ish, or your notes on this. So really the important one to identify here is c, which is the hypotenuse. The hypotenuse of a right triangle is only found across from the right angle. Okay? So, if we then have the a and the b, now, what I'm going to do here is I'm going to show you that it doesn't really matter. Because if you look at the equations, the difference between solving for a and solving for b is just the letters switching. So if we know that a and b are the legs, then really it doesn't matter which one we do. So what we're going to do first is the red. So I know that x, so if I'm doing the red, then I'm looking for a. So now a equals the square root of c squared minus b squared. In this case, c squared would be 4 squared. And then b squared would be the square root of 14 squared. Now in all your classes, I told you guys that the square root of anything squared is that something. So 4 squared is 16. The square root of 14 squared is 14. So we have the answer is the square root of 2. Okay, and that's how we leave it. We don't put like 1.41 or whatever. We leave it in its simplest radical form. So this is what you need to be doing on the test. If you do not leave it in its simplest radical form on the test, you will not get full credit. Okay. Moving on. So numbers 2 and 3 are very similar to that. Number 4, right. I'll do it with the black. So if I am looking for b, so now I'm solving for b, so it's b equals c squared minus a squared. So I'm using the black notations, not the red ones. I get 4 squared minus the square root of 14 squared, which then leads me back to the same thing. So now on to number 4. C equals a squared plus b squared. So we're going to go 4 squared plus 5 squared. Square root of 16 plus 25. The square root of 41, and that's my answer. We don't put down, so the square root of 41 would be 6 point something. And we don't put that down, we leave it as the square root of 41 because that is the simplest radical form. Okay, so these are everybody's favorites. Now, I said this in class, I think I said it in most classes, 15 through 18 are not required. If you already did 15 through 18, good job, you'll get extra credit for it. If you did not do 15 through 18 and you want extra credit, go ahead and do them, but they're not required. So, here we have 2 types of triangles. We have a 30, 60, 90 triangle and a 45, 45, 90 triangle. So 30, 60, 90 triangle, these are the tables. Remember, we have our base ratio, scale factor, and our final length. So the base ratio for a 30, 60, 90 triangle is always going to be 1 radical 3, 2. With the one leg being across from the 30, so that would be this one right here. The square root of 3 leg being across from the 60, be right there. And the 2 leg being across from the hypotenuse. Not across from the hypotenuse, being the hypotenuse. So, we're going to plug in square root of 6 over 2 there. Now remember that our scale factor, that's what we need to do now. We need to find the scale factor. And we can find the scale factor by dividing the final by the base ratio. So that gives us square root of 6 over 2 over the square root of 3. Now, that's going to end up giving me the square root of 6 over 2 radical 3. The square root of 6 divided by the square root of 3 equals the square root of 2. So our scale factor is the square root of 2 over 2. If you need this explained in greater detail, come and see me either like before class or at lunch, but before your final. Not your final, your chapter test. So square root of 2 over 2 all the way down. And then all we do is we multiply across. So 1 times the square root of 2 over 2 equals, and 2 times square root of 2 over 2 equals. And that gives the square root of 2 over 2 and just the square root of 2. So, number 8. I chose number 8 because it is a 45, 45, 90 triangle. So it's 1, 1, radical 2. Now here 2 is the hypotenuse, so it's across from the radical 2. Again, our scale factor is our final divided by our base ratio. So it's 2 divided by, so look what I did here. I am going around and I'm labeling each of the sides either 1, 1, radical 2 or 1, radical 3, 2, depending on where they are in the right triangle. So scale factor is going to equal 2 over the square root of 2. Now the thing here is now I need to rationalize my denominator. So I multiply it by the square root of 2 over 2. That gives me 2 radical 2. Now when I multiply the square root of 2 times the square root of 2, all I get is 2. Which should make sense. That's the square root of 4, which is 2. So now I have 2 radical 2 over 2. I'm going to reduce it. And so my scale factor is just the square root of 2. Multiply across, and there we go. So I do want to do number 12. Again, 12 is a 30, 60, 90. Is coffee ready?
Yes.
Cool. It's a 30, 60, 90. I'll get it in just a minute, sweetie. So that means it's a 1 radical 3, 2. Now the square root of 5 is across from our 60, so that means it's across from our square root of 3. Scale factor is base ratio divided by, or final divided by base ratio. So here we have the square root of 3 divided, or square root of 5 divided by the square root of 3. So again, we need to rationalize the denominator, so we're going to multiply by the square root of 3 over the square root of 3. That's going to give us a square root of 15 over 3. That's our scale factor. So then we just multiply across. 1 times radical 15 over 3 equals radical 15 over 3. 2 times radical 15 over 3 equals, well, 2 radical 15 over 3. Easy peasy. So, these next ones, what you have to do is you have to look at the angle and figure out what the correct trigonometric ratio is. So we got SOHCAHTOA going on here. Remember, that stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So what I would do, so for 19, so it says the tangent of x. So we identify our angle, x. We then identify the opposite, adjacent, and hypotenuse. So we know that tangent is opposite over adjacent. That's what we got from right here. And so we go the tangent of x is our O, 40, over our A, 9. And that's it. So number 20, we have the cosine of A. So we identify A, label opposite, adjacent, and hypotenuse. Remember, the hypotenuse is the longest side. That's across from the 90-degree angle. Adjacent means next to. So if this is my angle, this right here is the side that's next to it. It's actually part of the angle. The opposite is the one that it doesn't touch. Okay? So, we know that cosine equals adjacent over hypotenuse. Ca, that's the CAH up here. And so we have cosine of A equals our A number, 48, over our H number, 50. That reduces to 24 over 25. You just do the same thing. If it's tangent, you go opposite over adjacent. If it's cosine, you go adjacent over hypotenuse, and if it's sine, you go opposite over hypotenuse. So, these next ones, they're going to be a little bit different on the test. On the test, you're only going to be given two sides, so you're going to have to choose whether to use sine, cosine, or tangent. But on these ones, you can use any of them. Let me show you why. If I pick that one and identify opposite, adjacent, and hypotenuse, then the sine of x, which is my missing angle, is 55 over 73, which means that x equals the inverse sine of 55 over 73. Remember, inverse sine says what angle has that ratio as its sine. We do the same thing with cosine and tangent. Now here's the thing. If I plug any of those into my calculator, simply by hitting second tangent or second cosine or second sine, and then 55 divided by 73, 48 divided by 73, or 55 divided by 48, depending on which trigonometric ratio I chose, they're all going to give me 48.8 something, which rounds up to 49. So 49 degrees is the answer. So if I were you, what I'd do is I'd just pick one, sine, cosine, or tangent, and then just run with it, and always use that one. That'll just make your life easier. Or you can switch them up. It doesn't matter. If you're doing it right, you're going to get the right answer. So, just on 30, again, working with people over the past couple of days, there's some confusion on opposite versus adjacent and hypotenuse. Remember, the hypotenuse is the long one. It's across from the 90-degree angle. The hypotenuse and one of the sides make up the angle that we're talking about. And that side that joins up with the hypotenuse to make our angle is the adjacent one. It's right next to the angle. And then the other one that the angle doesn't touch at all is the opposite. It's on the other side of the triangle. So for number 30, O would be 9, A would be 40, and H would be 41. So last group. So here we have number 39. We have this angle, 19. We have our opposite and our hypotenuse. So we want to look and we go, okay, what trigonometric ratio relates opposite and hypotenuse? And the answer is sine. Sorry about that. So we know the sine of 19, I don't know why that's, what happened to the 1, there we go, equals x over 17. Multiply both sides by 17. We have 17 times the sine of 19 equals x over 17 times 17. So what we did there on the second step is we want to get the x by itself, so we multiply both sides by 17. This gives us 17 sine of 19 equals x. When I plug that into my calculator, I get 2.7. I think I may have plugged in 17 sine 9. If I did that, then that answer is wrong. I don't have my calculator on me, though. So, hold on just a second. And what I'm going to do and we get 5.5. So, moving on, like nothing ever happened. 29 degrees, opposite hypotenuse. Again, opposite hypotenuse is the sine. The reason I'm doing another sine problem is because where the x is. In the previous problem, 39, the x was in the numerator. Here, the x is in the denominator. This isn't really that much more difficult, but people tend to freak out about it. So this is all you got to do. You want to multiply both sides by x. So we have x times the sine of 29 equals 17. And then we want to divide both sides by the sine of 29. Rama, shush. And we get 17 divided by the side of 29, and that is x equals 35.1. If you have any questions, go ahead, shoot me an email. If not, I'll see you all ready for the test tomorrow.